A couple of short little thoughts about projectile motion, something that we're going to discuss in class, but something I just need you to understand conceptually. Projectile motion occurs when an object is given an initial velocity. Maybe you throw it out horizontally, maybe you shoot it out horizontally, maybe you shoot it at some angle or throw it at some angle, but you give it an initial velocity and you're somewhere relatively near the Earth's surface. You're not way up towards outer space. And I should just say space in general. And because of that, and it doesn't have any rocket boosters or anything else, so it moves under the influence of only gravity, no other forces. That's what occurs with projectile motion. Now, here's two statements that I need you to know. How long an object is in the air, aka how much time it has, is solely dependent upon the y-axis, and how far the object goes is solely dependent upon the x-axis. Projectile motion is like two basic problems that you have done way back when, that you did whenever you did basic kinematics put together. Y-axis, just a free fall problem, dropping something, and x-axis, just a constant velocity problem, and a projectile motion is the combination of the two. Now, if you think about something falling, like this, for example, it is accelerating because of the acceleration of gravity here, or the force of gravity. So originally, it doesn't go very far, and then it goes a little bit further, and then it goes a little bit further. With each passing second, it goes further and further and further because its velocity is increasing, so the amount of distance it can cover grows. Think about the equation S equals ut plus 1/2 at squared. With each passing second, the amount of displacement you are able to cover is according to time squared. Now over here, imagine that we have a cannon. The cannon shoots a cannonball, and if there was no gravity, it would go straight like this, and life would be happy. Constant velocity. There is no force after the cannonball's already shot, right? It's just in free motion. Newton's first law, an object in motion wants to remain in motion at a constant velocity and in a straight line. But while it's traveling, and it wants to travel like this cannonball is under the influence of gravity. So let's put a little FG maybe here. And because it's under the influence of gravity, it's going to fall. Now, if the cannonball were just dropped, it would fall like this. It would go a little ways after 1 second, a little bit further after 2, even further after 3, and then after 4 seconds would fall even further. And it's the combination of those two that we see with projectile motion. In the x-axis, after 1 second has passed, it would be over here. But because of gravity, if you will, it has fallen a little bit. Notice that it lines up with how far it would have fallen if you had just dropped it. Then after 2 seconds, it's now over here, right? X-axis, it would have traveled over there, x-axis being your left and right, y-axis being your up and down. So after 2 seconds, maybe it would have been over there, but it's going to fall a little bit, just like if we were in free fall. And so here's how far it would have fallen, as if you had just dropped it. And then after 3 seconds over here in the x-axis, but now we're going to fall even further because we've been picking up speed in the falling in the y-axis, so it has to fall even further. After 4 seconds, it falls even further down. But notice how far it goes is purely controlled by the x-axis, how far it gets, and how much time it has in the air, aka how much time before it hits the ground, is purely controlled just by as if you had just dropped the cannonball. Now, this idea of something being launched and something being dropped would hit the ground at the exact same time feels kind of odd, and so we're going to talk a little bit more about that in class and do a demo.